This is just going to be a short run through showing how the derivative of a vector valued function turns into the individual derivatives of its components. And we'll start with our traditional understanding of a derivative, or the analogy of that in vector form, by looking at the limit of the difference quotient. So if we were setting that up, it would look something like this. R of t, or rather r prime of t, is going to be equal to the limit. And normally we would use the limit as h goes to 0. Here, because we've already used h as part of our vector valued function, we're going to go ahead and use delta t to represent that quantity. So we would let that go to 0. And then the remainder of the difference quotient would look like t plus delta t minus r of t, all divided by delta t. So now let's go ahead and figure out what these two quantities are. Generally, I approach these by first figuring out what r of t plus delta t will be, and then we'll subtract off r of t. So let me just, as an aside, find r of t plus delta t. So we'll evaluate that in up above here. So this is f of t plus delta t, comma, g of t plus delta t, comma, h of t plus delta t. So that's that. Obviously, we know what r of t is. Just rewriting that from above, we've got f of t, g of t, and h of t. It's a little redundant, but that's okay. Now again, through our difference quotient, we're supposed to take the difference of these two quantities over here. So let's go ahead and do that and start setting up our limit. It's going to be equal to the limit as delta t goes to 0, and r of t then is f of t plus delta t, g of t plus delta t, and h of t plus delta t. Again, we're subtracting off r of t, so minus f of t, g of t, and h of t. And all of that gets divided by delta t. So there's your evaluation, and you can probably see how these pieces are going to come together here, but let's start writing this out just to finish it off. Limit as delta t goes to 0. In the numerator, we're going to do the subtraction. This is going to be f of t plus delta t, subtracting component by component, minus f of t. We're going to have g of t plus delta t minus g of t, and h of t plus delta t minus h of t. And again, that's still all being divided by delta t. So we're a little bit closer. The last step is to essentially divide delta t from each one component by component. We now have the limit as delta t approaches 0 of f of t plus delta t minus f of t all over delta t, g of t plus delta t minus g of t all over delta t, and h of t plus delta t minus h of t all over delta t. And from there, you have exactly what we want to show, which is that we can take the limit component by component here. I won't actually write that out, but ultimately we can see now that this is just going to be f prime of t, g prime of t, and h prime of t. again, just illustrating that we can take the derivative component by component through a vector valued function.